Okay, so in this video we're doing the tutorial on logic. Now, the tutorial on logic is very good. They have questions that are very hard, questions that are very good for the exam. If you know all this, you should be good for the exams, right? Now, I'm going to take it quite easy with logic, especially when I do my calculations, because obviously I need to work it while doing the video. So you can speed up the process, speed up video settings on this YouTube video. You can speed it up if you want. But let's get to it, right? So the first question will ask, right, which of the following symbols, and I'm going to tell you all the symbols what it means, because you should know. Okay. The first symbol here represents a process, right? A process. A process or an action the system must take. The second one over here is a parallelogram. I remember this in grade 12. Prove that no, we did it in grade 10. Prove a parallelogram. I hate that maths, man. Prove that vertically opposite sides are equal. Anyway, not the point. Point is a parallelogram is a slanted square. So what does this is? This is for input and outputs, right? So on inputs and outputs of the system is represented as a parallelogram. This is a decision. So it's a decision. It indicates a decision in the system, so like a yes or no. Whenever you say yes or no coming out from there, it's a decision, which is that a decision has to be made. Decision structure, that's also a name for decision structure. So if they ask how much decision structure there in the system, it's just one. Even though it's just yes and no, you're counting the actual structure. These are all structures. This over here is a start and end point, so anytime you start and end the system, it'll be represented as this. This over here, it's just a random thing to confuse you. Doesn't really matter, yo. Oh, what's the answer? Which of the following charts represents a point in which a process? So it's obviously going to be where data is entered. So you have to be very critical about it. Yes, a point in process. Process is everything, but where data is entered. So wherever data is entered, right? The system, you're giving it input in the system. So answer will be B. Now, you see, I will argue that whoever did the memo just saw process and put that. Because where data is entered, they're being specific. You're putting data in the system, so it has to be input. It has to be. People can correct me if I'm wrong, but I'm assuming it's input. Yeah, I'm assuming it's input. I think so, yeah. Which allows a program implementation to be independent. So, independent, right? Well, somebody actually taught me this. Independent is an interpreter. Somebody actually taught me this. So whenever you see independent, it links with an interpreter. So they'll give you like a compiler and an interpreter, and they'll say which is independent in the multiple choice. I is independent, and then we got I over there. So that's how you know, right? So answer be interpreter. So you don't have to read the question. Now, what does this question actually mean? A program implementation to be independent of the characteristics of the host CPU. Okay. So anything that's independent can be on its own. There's no interaction, there's no effects. Host CPU and interpreter are independent, meaning they can be worked together, but they don't affect one another. If it wasn't independent, then the interpreter will have to change or be modified to suit the CPU. Because different CPUs, for example, think logically. Let's think logically. What product only works for specific product? For example, when you call someone, right? Everyone has Cell C, Vodacom, or MTN. So let's say if there was a specific apartheid error where you only allow Cell C users in a building. So the block building is dependent on your SIM card. You see, dependent, it depends on the SIM card. If it was independent, everyone can go. It doesn't matter. There's no interrelation between the two. So it doesn't affect the two. So that's, yeah. So independent, there's no effects, right? Stats 140, there is no effects, null hypothesis. 3, right? This is where the calculations are going to begin, right? Okay, so let's do it. What will the output of now? I told you this is my video on flowcharts, very critical video of how to do a flowchart. Before you approach these questions, you want to do the actual flowchart. It's called a dry run. You want to do it from start to finish, then answer the questions. You can't just be doing questions and doing the calculation. No. Do the questions first, right? Right, let's start. So, let's do this, right? Now, I'm clearly seeing there's going to be the way this is structured. I think it's, yeah, you see, I'm not sure, because that's supposed to be here, isn't it? So, x is equals to, I'm not sure how, I'm sure it's greater than equal to, if I'm not mistaken, eh? Pretty sure. X, is it x? I don't know what symbol is it though. Is count. Oh, wait, yeah, is count greater than equal to 6, okay. So let me just write it over here. Okay, count greater than equal to 6. Alrighty, so let's start, right? So the way I start is very easy. I go in iterations. So my iterations are my rows going down, my numbers. But you will see what I'm trying to mean. Input number. They should tell me what number I must input. What output of the flowchart if the value of a number is 3. Alright, 100% num. Input is the num. Okay. So let's put 3 in the system, right? Now I'm going to look at my variables. My variables, how do I do it? Is very simple. Variables are like things in there, like the formula, like the subject, like basically like num is a variable, count is a variable, sum is a variable. It assigns values to it, right? Assign numbers. And variable because they can't change. So sum, count, and num. Sum, count. So obviously no repetition. So although there's 2 counts, just count, like, you know. So we got sum. So I'm just going to do in different color. Sum. Then we got count. And then we got num, right? So first step, get the variables, right? Now we're going to do our rows. So input num. So we're going to start with the num of 3. Num of 3. So already if I look, I can put num as 3. Now 3. Basically what it's saying is set 2, count to 2 and sum to 0. But I know sum is going to change to some number. So, but you can still say it here. You can say count is 2 and sum is 0 over here. But in my iteration going down, I'm going to change sum. So I'm just going to erase from 0 and put whatever this is. So I'm not going to put anything now because I know sum is changing. In my iteration is going down, means. Yeah? Okay, so, okay, count is 2. Sum is 0. Sum is equals to sum plus count. So 0 plus updated count is 2. 2 times num, updated num is 3. 2 times 3 is 6. So sum is 6. So if I had 0 before when I put that, I can erase it and put 6. Is count greater than, is greater than equal to 6? Yeah, isn't? Count is greater than equal to 6. No, sorry, count is still 2. Okay, so no. Then we say count equals to count plus 1. The updated count we got is 2. So 2 plus 1 is 3. So, so you see, this now to raise, because the count was actually going to change also. So no problem. So you see how in one iteration your variables change. And then now we go back. Now once we go back, we are done with the first iteration. Now, going back, right, let's see. Sum is equal to sum plus count times num. Okay. Sum plus count. Our updated sum is 6 and count is 3, 6, 7, 8, 9. 9 times num. Updated num is 3. So 9 times 3 is 27. So our sum now is going to be 27. So sum is equals to 27. Yeah. And then is count, so count now will remain the same because we never affect it, so it remains at 6. No, sorry, it's going to be, no, sorry, I mean num. The num won't be affected. But now count is same, count plus 1, so updated count is 3, 3 plus 1 is 4. So this iteration is done. Okay, so I'm just going to look, I'm getting big numbers. Oh, these numbers are actually big, okay, so I'm fine. So I'm just going to get my calculator out. I forgot these numbers are actually big, so just hold on 1 second. Just let me get my calculator out. Not that I can't calculate, I can, but you know, just to be accurate. Okay, our next iteration, it sends us back because obviously this arrow is going back now because count wasn't 6. So now we go back. Sum plus count. Sum plus count, 27 plus 4 is 31. 31 times num, updated num is 3. So 31 times 3. 31 times 3 is 93. So your updated sum is 93. Your count, okay, I know it's going to change, but num is not going to change. Num is going to be 3. But obviously now count plus 1. So is it count 6? No, count is 4. So you go there and add count plus 1. So it's 5. Because 4 plus 1 is 5, huh? Now, this is probably going to be my last iteration. Okay, sum is equal to sum plus count. 93 plus 5. 93 plus 5. 93 plus 5 is 98. 98 times 3 is 108. So my sum is 108. Wait 1 second. 108. So 100. Why isn't working now? 108. Okay, so I see what's the problem. It's 2 on the right I'm writing, okay. Okay, 108. And then the count now, is it 6? No. So it's count plus 1, so it's 6. And obviously year is going to be same, like. Okay, so it's probably going to be another iteration. Because the count is 6 here, but we still have to go to the arrows to get to here. So we can do another iteration here. So let's do another iteration. Sum plus count. 16. 16 times 3. That is 48. Sorry, 10. No, sorry. 10 plus 6. Wait, something's not adding up here. Because how can this number be greater than 93? Hold on. 27 plus 4. I'm just going to double check 1 second. Okay, sum plus count. Why did I get a low sum out there? Oh, wait. Sum plus count. Okay, I think I made a mistake there. Let's see. Sum plus count. Okay, I probably made a mistake there. 93 plus... Oh, no, sorry. It's supposed to be 108 because my 8 went away, isn't it? Yeah, my 8 went away. See, that's confusing me, man. My 8 went away. So, oh, man, my 8 is still going... What is wrong with you, man? What on earth is wrong with you? No, see, I'm irritated now. How that 8 just went, man? Disrespect. 108 plus 6, that's 114. Times 3, that's 126. So my new sum is 126. Is count equal to 6? Yes, count is actually equal to 6. Yes, so my count is 6. Yes, correct, count is 6. So yes, output sum. So my num staying the same. Output sum, the sum is going to be 126. So we got a problem. It's not in there. Okay, so I just paused my video because I was wondering why I wasn't getting to an answer. I made a mistake over in this iteration. 93 times 5, and I'm supposed to say it. 93 plus 5 times 3 is not 108, it's 294. So it's actually 294 this. So when I said 108, that was wrong. The calculation is wrong. Process is correct, so 294. 294. 294. Now the next iteration I'm going, because over here now what's happening, it's count is over here, so iteration. So 6, yeah, count made this 5 plus 1, that is 6. We got 3. Okay, now the next iteration we're going to go is this one. So our sum now is going to be 94. 294 plus 6, that's 300. 300 times 3 is 900. So 900 That is sum, then the count will be 6, remains the same. Num will be 3. Is num count 6? Yes. Display sum. The sum, obviously, it's going to be this line, is 900. So the system is going to display 900. C should be the answer. Number 3, C. So the calculation is, it's very easy to mess up calculation. 93 plus 5 times 3. I don't know how I messed that up, but it makes sense, right? How many times will count equal to count plus 1 execute? Okay. So how many times did we go through this block? Very easy. Most of the times when they give you this answer, it'll be the iteration minus 1. 1, 2, 3, 4 iteration minus 1 is 3. I'm not even going to look at the memo. The answer should be 3 is E. 4, D. Okay, probably not. No, yeah. It's 5 iterations. Like 1, 2, 3, 4, 5 iterations. So minus 1 is 4. Yeah, 4 is the answer C. I never even have to look. Because what I've realized is this, at the end of the day, you're going to go and saying no over here for 1, 2, 3, 4 iterations. You said no. This iteration, you allowed it to run because it said yes. So it's only one yes you go and to the end. So obviously just take how many iterations minus 1, then you get how many times this executed. Because, you can just say you went to it 4 times because you went back 1, 2, 3, 4. You see what I'm trying to say? How many processes boxes are there? 1. So processes are, I told you, rectangles. 2, 3. Should be 3 processes, yeah? Should be C, 5, C. Yeah, correct. Told you. See, input is a parallelogram, you see. Decision, that. End is like a thing, oval. What structure represented by X, Y, Z? Now, what structure is this? This is called a loop. So you see how a loop is like a loop? That's a loop. But this won't be a loop. Because, if you see, from here it's going to another block, this block, this block, this block. It makes like 3 arrows going in a rectangle. But a loop is like a loop, right? It's a loop. This is not a loop. Because if it was just this block, for example, going to this block and then coming down, so that coming down, that's a loop. But because it has 3 blocks, it's a repetition. A loop is like 2, a repetition is 3. And see, there's 3 variables, that's a repetition. So it's B. Correct. If you had just like X and Y, then it's a loop. So loop is 2, repetition is more than 2. What will happen if the initial value of count values are 2 to 7? What will happen if the initial count value changes from 2 to 7? And the num value is 4. Okay, so if initial is 2 to 7. So, okay, just let me erase all this. Let's erase, okay. So 2, okay. So what happened if count was 7? And then the num value is 4. So the num is 4. So let's see what will happen, right? Okay, now I hate this word, document. Okay, so num is 4. Okay, so very easy. You start with 4, right? Your count is 7. I already know 7 is greater than or equal to 6, so I'll say yes. But let's see. So first iteration, so let's say sum num count. We know we're setting num to 7. Sorry, what are we setting num to? Num value is 4. So sum is equals to sum plus count. Our sum is 0 plus count, which is 7. 7 times num. 7, 14, 21, 28. Sum is 28. Obviously your count will be 7. Then, is count greater than or equal to 6? Counts. Yeah, it's 7. Yes, end. Output sum, the sum is 28. Please tell me that it's 28, yeah? Oh, yes, sir, A. Uh, A. 7 is A. 7 is E. Oh, E. A and C. Okay, so why is it A and C? Count, yeah, oh yeah, this makes sense, yeah. Because count plus one will never execute, we never go through a process because we never said no and went through this process. So that actually correct, I never see, yeah. Correct, so it's E. E, A and C. What are the following is not part of phase 2 of the programming process? This is the programming process, we're going to do it now, but basically, it's going to be output. Defining the problem is going to, okay, so it's got to see not formatted, right? Okay. Define the problem is number one, right? In defining the problem, you say the input, process, and output. So that's the first step. So that is why over here I said it's going to be output because it's not part of phase 2, it's part of phase 1. That's all part of phase 2, all these things. Then let's see, what is 2? Outline the solution. So 2 is outline the solution. And then see, it's hard now to see. Okay, I'm just gonna tell you what it is. Okay, so number 1 is define the problem, right? Number 2 is outline the solution to the problem. Number 3, you need to develop an outline or an algorithm for the flow chart. Number 4 is to test the algorithm, right, after flow chart. Number 5 is to code the algorithm, and the last one is to maintain the documentation, right? So 5 was IV. I'm just gonna check something. 9 is B. Okay, so wait. See, I'm not sure. Oh yeah, wait. IV 5. Yeah. So what I said is 100% correct. Actually, 100% correct. Let me check something. B. Yeah. Oh yeah, B. Yes, B. Perfect. Because it's out. This thing is formatted wrong. Okay. So same thing we do over here. Input the value X. Input the value sum 0, and then we do some stuff. Okay. X sum and Y are our variables. So X sum and Y. Input value X and sum. Sum will change. I know that. Okay. So I can put X now as 0, and I know it's going to be 0. Okay, sum. Okay, Y is equal to sum plus X. Sum now is 0. 0 plus X. 0 plus X is 0. And then sum is equal to, oh sorry. And sum we did 0 also. Okay, so everything is 0 over here. Strange, but it works. Is sum greater than equal to 5? No. We say sum plus 2. That makes it 0 plus 2 is 2. Y is equal to sum plus X. 2 plus 0. It's 2. The X will remain the same as X, right? Then the next one we're going to do is sum greater than equal to 5? No. Sum plus 2. So this is 2 plus 2 is 4. 0, X will stay the same, but obviously sum plus X is 4. Sum plus X. Y is equal to sum plus X. 4. Probably this could be the last one. No. A sum plus 2. 6, 0. Sum plus X. 6 plus 6. Is sum greater than 5? Yeah, it's 6. Yes, output sum. The sum is 6. So it should be 6 as answer. A. 10. A. Correct. 100% correct. How many times sum plus 2 is executed? Let me, I said 4 earlier on. I can just say iteration minus 1. So 1, 2, 3, 4 should be 3. See, without even working it out. D is 11D. Oh, 11 is A. Okay, makes sense. So I think you have to count, right? Count. It's better to count. My thing might not always work. So how many times you went back? 1, 2, 3. 11 is A. Why is it saying A though? I'm confused. You went here 3 times. Because here, I can argue over here. Because the memo wasn't 100% wrong. The other questions also 100% right. When sum was 0, it went there, executed 1. Sum is 2, it got executed. Sum was 4, it got executed. That's 3. Alright, so 3 is the correct answer. You got and the last one was sum was